All right, good morning, good afternoon, good evening, depending on when you are listening or watching this video from. This is the voice of Tutor Philip. All right, so today we're going to be seeing a very interesting and common topic in physics called motion. All right, now you have to know that there are two category types of motion. There is a linear motion and there is a gravitational motion. Okay, so today we're going to be treating linear motion. All right, then maybe in my next content or in my next video, I'll be talking about the gravitational motion. Okay, now if you are new in this channel, please kindly subscribe, kindly like, and kindly share the video. All right, at least when we see that we have likes and we have comments and we have shares, it gives us more morale to post more content like this that will be helpful to you. Okay, so guys, as you can see, these are the major formulas related to linear motion. All right, these are the three major formulas, and you can see what they all represent. All right, you can see what they all represent: v final velocity, u initial velocity, just like that. You can take a pause, all right, and observe them carefully so that you can really understand what they stand for. Okay, and also there are three major laws that you have to take note of before you can solve questions related to linear motion. All right. Number one, they are being displayed on the screen right now whilst I'm talking. All right. So number one is when a body starts from rest, initial velocity u, this is the initial velocity, or this one is equal to 0 when the body starts from rest. Number two, when the body comes to rest, final velocity v is equals to 0. Number three, when the body is moving with a constant velocity, acceleration a is equal to 0. All right. So guys, I'll be seeing you in the video where we'll be taking question and answer. All right, so you are welcome to the next video. Please kindly be aware that we are currently on the motion series. Like the linear motion, we're going to be solving series of questions under linear motion. So it's very, very important for you to subscribe, because the question you're seeing right now is actually an easy question. Okay, so we are going to be solving more difficult examples. All right, so this series is going to help you understand the entire content about motion. All right, everything you need to know about motion, this series will help you. All right, so this is the first question, and don't forget, drop in the comment section the kind of question you want me to solve or the next topic you want me to treat once I'm done with this particular series of motion. Don't forget that I'll be checking the comments to see those of you who actually showed me or wrote what you want me to teach after the motion series. Okay, now this one says a car accelerates uniformly from rest at the rate of 3 meters per second square. So I'm going to go ahead and write solution. Okay, solution. So the car accelerates at what? 3 meters per second square. So acceleration A is what? 3 meters per second square. In fact, the shortcut for you to be able to identify acceleration is when you see anything like meters per second square, then automatically you know it is acceleration, because that's the SI unit for acceleration. Okay, for 8 seconds, so time is 8 seconds. Calculate the distance. We're looking for distance S. I'm going to put question mark, covered by the body during this acceleration. Okay, guys, this is A, this is T, this is S. And read the question. They said a car accelerates from rest. I remember I told you that one of the three major ways you can solve questions regarding acceleration. I told you always know what to put for the initial velocity anytime you hear that something accelerated from rest. What do I mean is this? They say that a car accelerates uniformly from rest. Now, when an object accelerates from rest or move from rest, what does it mean? It means that initial velocity u is what? 0. Okay? Initial velocity u is what? Is 0. That's what it means there. So I'm going to draw my line and I'm going to continue solving on this other side. All right, so we can have everything fixed on one box. Okay, now check the formula. Which of the formula here have both A, T, S, and U? A, T, S, and U. Let's check. This is A, T, U, and V, so we can't use this. This is S, T, U, T, A, T. All right, I think you can go with this. I think you can go with this. Why? Because it contains what we are looking for. We can't go with this because there is V here. All right, there's V here, okay? And here there is no V, so we can't use this. Let's work with this. So S is equals to UT plus 1 over 2 AT squared. So I'm looking for S. I'll bring down my S equals to, my U is what? 0. 0 times what is T? T is 8 seconds. 8 plus 1 over 2. A is what? A is 3 times 3. T is what? Still the same 8 times 8, but there's a square here at the top of T. So I'm going to put square here. All right. So I'll continue solving. S is equals to 0 times 8 is 0. All right. Automatically, this side has gone out because it is 0. So I'm going to bring my 1 over 2 times 3 times. Now, what is 8 square? 8 square means 8 times 8. All right. So 8 times 8 means what? 64. Okay. So instead of putting 8 square again here, I'm going to put 64. All right. So the next thing I'll do, I'll multiply everything at the top. 1 times 3 times 64. All right. All right. So 1 times 3 times 64. That will give us 192. All right. 100 and what? 92. So let me draw the line downwards. So S is equals to what? I multiplied everything here. I multiplied 1 times 3 times 64. So I got 192 all over this 2. Bring it down. Now you divide. 192 divided by 2. That will give us what? That will give us a total of 96 meters. 96 meters. So guys, that is it. Don't forget to subscribe because this one you are just saying now, this is the beginning. By the time we start entering tough questions, you'll be amazed how that they are so easy to solve. Questions that are very difficult, mind-blowing questions. You just stick with me. Subscribe, like, share, and comment. All right, guys, I'll be seeing you in the next session.